Hey guys, today we are going to talk about particle theory. Now, this should be a review from last year, but let's go ahead and review what you should already know. So, particle theory is everything is made up of particles, everything. The air around you, the drink that you drink every day, your food, your clothes, everything is made of particles. And those particles all behave a certain way depending on what state of matter they're in. There is space between each of those particles, and depending on what state you're in gives you the certain amount of space that you have. They're always moving, and these particles are very much attracted to each other. So when we talk about gases, now gases include air, and then the pure gases like helium and hydrogen. There's lots of different kinds of gases, and the particles in a gas, they're going to move very fast, and there's going to be lots of space between them, okay? They are also going to move super quickly and in every possible imaginable direction, and they're going to be bouncing off their container, whatever they're in. And they don't have any shape or volume. They just fill up the space that they're in. So you can take just the same amount of gas can fill up a tiny little jar, and it can fill up a great big balloon. They fill up whatever shape or container that they're in. And they have a weak attraction between the particles. The particles don't want to connect with each other. Now, liquids, if you look at this picture of liquids like we have right here, you can see these fancy little arrows. And they're trying to show that the liquid molecules kind of move around each other. It's what gives it the flow. Okay, now gas can also flow. You can pour a denser gas into a less dense glass and it will flow down. But liquid you think of, you can pour. The particles are much closer together and they move more slowly, but they're definitely still moving. They're loosely bonded. That's why they get that, sliding over kind of motion. And they have a definite volume, meaning you can measure how much there really is, but they don't have a shape. So if you have a beaker, that 500 milliliter beaker, that great big beaker that we have, if you pour 200 milliliters of liquid into that beaker, it's going to take the shape of that beaker. Well, if you take that same amount of liquid, that exact same liquid, and you pour it into our Erlenmeyer flask, it's going to look more triangle shaped. It's going to take the shape of whatever it's in. And then you have solids. And if you look at this image right here, you'll notice that in a solid, those particles are definitely lined up. Okay, they are very, very close together, and they more vibrate versus trying to get past each other. So they have, they're tight packed. They don't move around very much, but they vibrate. They have very strong bonds. For the most part, it's very hard to break most solids. Now you're thinking, well, I could crumble a cookie and it's solid. Right, but when you get down to those molecule of cookie, you would have a hard time breaking those apart. And they definitely have their own shape and volume. My phone is a solid. It has a definite shape and a definite volume. Now, particle theory says that the temperature of a liquid, solid, or a gas refers to how fast its particles are moving. The faster the particles move, the higher the temperature. And this is going to make sense to you if you think of water. When water is really, really cold, has a really low temperature, it's a solid, okay? And when it has a really, really high temperature, it's a gas. And in there, you have that medium temperature where it's a liquid. So we're going to start with that medium temperature. It's a liquid. It can flow. It's chill, right? And then you give it a lot more temperature and it turns into this gas, and it's going to be moving around a lot more, okay? And then you have the low temperature where it just kind of sits there, okay? So when particles are heated or gain energy, they move faster and the spaces between them expand, okay? And when particles cool down, those spaces get closer and they lose energy. It's called contraction. And if the energy, if there's enough energy change, if there's enough temperature change, you're going to have a state of matter change. This is a really great diagram that I want to leave you with. It really kind of talks about how things change. And if you follow those arrows, when you're going from a solid to a liquid, you melt So you're gaining energy. When you're going liquid to a gas, you're gaining energy. But when you go from a gas back to a liquid, you're releasing energy, you're losing energy. And if you go from a solid to a gas, that's called sublimation. And it's a really cool thing that you can see with dry ice, which is something I know you guys really want to do. And if we have time, we will definitely do it. If you have any questions, don't forget, you can contact me through email, come up to me in class and ask a question, or leave a comment.